Section 7.5. Our objective today is I can use the side-angle-side similarity theorem and the side-side-side similarity theorem to prove triangles similar. Alright, so first of all, the side-angle-side similarity theorem says if the angle of one triangle is congruent to an angle of another triangle, and the sides including those angles are in proportion, then the triangles are similar. Alright, so basically, if I have this triangle and this triangle, where this is A, B, C, and this is X, Y, Z, and I know this angle is congruent to this angle, and I know this side is 3, this is 4, this is 6, and this is 8. So it says if angle B is congruent to angle Y, and AB is to XY as BC is to YZ, then triangle ABC is similar to triangle XYZ. Okay? And notice that the sides are in proportion because AB is 3, XY is 6, and BC is 4, and YZ is 8. So that is a true statement. Okay, so then we can say those triangles are similar. Okay, and then the second theorem is the side-side-side similarity theorem, and it says if the sides of two triangles are in proportion, then the triangles are similar. So, so if I have triangle ABC and triangle XYZ, and I know this is 3, this is 2.5, this is 4, this is 6, this is 5, and this is 8. It says if AB is to XY as BC is to YZ as AC is to XZ. Okay, so in other words, 3 is to 6 as 4 is to 8 as 2.5 is to 5. That's true. Then triangle ABC is similar to triangle XYZ. Okay, so let's look at some examples here. Example, our triangle PQR and triangle TSP similar. Oops. Okay, so here's the picture. Okay, so I have this triangle and that triangle. This is Q, this is P, this is S, this is T, and this is R. And I know that SP is 8, TS is 6, and PT is 12, QR is 12, PQ is 9, and RP is 18. Okay, so we know something about all three of the sides of each triangle, so let's compare the proportions or the ratios. So let's compare PT to RP. That's 12 to 18, which is 2 to 3. Then let's compare TS to PQ, which is 6 over 9 or 2 over 3. Then let's compare SP to QR. And remember, you must compare corresponding sides. Okay? And so, since PT is to RP as TS is to PQ, as SP is to QR, then triangle PQR is similar to triangle TSP by the side-side-side inequality theorem. Okay, but what if I know this information about the picture? Okay, so we have the same picture. I have Q, P, S, this is T, and this is R. And now I know that ST is 7. I know SP is 7. TS is 6. PQ is 9. QR is 10.5. And measure of angle S is 80. And measure of angle QPR and QRP equal 100, so that means this one must be 80. Okay, so we know measure of angle Q and measure of angle S are 80, so then we have to show that the two sides that form that angle are in proportion. So we show that SP is to QR, so that would be 7 to 10.5. So if I multiply by 2, that gives me 14 over 21, or 2/3. And then I do TS to PQ, which is 6 to 9, which gives me 2/3. And since measure of angle Q equals measure of angle S, and SP is to QR as TS is to PQ, then triangle PQR has to be similar to triangle TSP by the side angle side similarity theorem. Okay. So let's look at this picture. So this is C, this is A, this is B, this is D, F and E, and this is a right angle, and I know this is 7, this is 6, this is 14, and this is 12. Okay, so I'm going to set up my ratios of small to large. Okay, so we have congruent angles, so now we have to see if the sides are in proportion. So 6 is to 12, which is AB is to EF. And then I have 7 to 14, which is CB to DF. Okay, those both equal 1/2. So by the side angle side similarity theorem, we can say triangle ABC is similar to triangle EFD. Okay. Next one. So this is I, H, and G, and this is 8, 3, and 6. And this is J, K, and L. And this is 24, this is 9, and this is 18. So notice in this example, I don't know anything about the angles, but I know about the sides. So for this one, GI corresponds to LJ. So GI is 8, LJ is 24. So that's 1/3. Then HI corresponds to KJ. So I got 3 over 9, or 1/3. And so then GH corresponds to KL, so 6 over 18, which is 1/3. So by the side similarity theorem, we can say triangle GHI is similar to triangle LKJ. Okay, and let's look at one proof. So given that AX is to XC as BX is to XD, prove that AB is parallel to DC. And then here's my picture. Okay, so number 1 is my given. AX is to XC as BX is to XD. That's my given. So AX is to XC as BX is to XD. Okay, so we have two sides of one triangle in proportion to two sides of the other. Then we can say angle AXB is congruent to angle CXD by vertical angle theorem. So this angle is congruent to that angle. So then we can say that triangle AXB is similar to triangle CXD by the side angle side similarity theorem. Okay? Then if they are similar, then angle A is congruent to angle C, or angle B is congruent to angle D, because corresponding angles of similar triangles are congruent. Then if angle A is congruent to angle C, Those are alternate interior angles, so I have two lines cut by transversal, and alternate interior angles are congruent, therefore AB must be parallel to DC.